Just the rules of method overriding are that the method of overriding will be initiated. The method of overriding will be initiated only when the superclass inherited method and the subclass methods have the same name and the same list of arguments. The method of overriding will be initiated when the superclass inherited method and the subclass overrided method has the same name and the same list of arguments. Once the same name and the same list of arguments are there, then compiler will initiate the process of overriding and initiate for the overriding rule. The first overriding rule is with the return. The superclass inherited method return type is primitive or void. When the subclass overridden method return type should be the exact primitive or void. Okay. If the superclass return type is a class or any entity, then the subclass return type can be the same entity or even the specialized entity. Okay. If the superclass return type is a class, then the subclass overriding method return type can be the same class or even its subclass. Okay. If the subclass overriding method return type is a superclass when compared to the superclass method return type. If the subclass overriding method return type is bigger when compared to the superclass method return type, then it will be a comparative method. And static methods should not be overridden by non-static methods as well as non-static methods should not be overridden by static methods. Static methods should be overridden by static methods only, non-static methods should be overridden by non-static methods only. Okay? Either both can be static or both can be non-static. Okay? If one is static and one is non-static, then it will be a comparative method. Okay? And let's consider that. Okay? The access levels. Okay? As we go to the subclasses, subclass overriding method can have the same access level or even higher. Okay? These are the things that we have discussed in the previous classes. Now, at the time of compilation, to which method it is bound? At the time of compilation, let's consider both are non-static. At the time of compilation, the EMP reference, we have created an object with the name, we have created an object for employee class, okay, and the reference variable name is EMP, and using EMP we are calling test. Okay. Now we are calling test method in the something like fifth statement. Okay. The calling statement in the fifth line at the time of compilation will be linked to the method in the employee class or will be linked to the method in the person class. The calling statement in the fifth line. In the fifth line we are calling the test method. Is that test method linked to the test method of the employee or test method of the person? At the time of compilation. At the time of compilation, definitely, okay, the test method to the test method of the employee will be linked. Just because the compiler what it will do, it will create an object to employee. It will create an object to employee. Sorry, the object is not created at the compilation time. The compiler what it will do? It will say what is EMP? What is EMP? EMP is a reference variable of that. What is the data type of EMP? Employee class. So it will link to the method which is present in the employee. Now, do we have a method which is specific to employee? Do we have a test method with non-class which is specific to employee? Yes or no? Do we have a test method which is specific to employee class? Yes. So it will not consider the inherited test method. So at the time of compilation itself, okay, let's consider that we have person class, and we have test method, and we have even employee class, and we have so at the time of compilation, if I create an object using employee EMP equal to new employee, and if I call emp.test, then at the time of compilation it will check in the employee class do we have any test method? Do we have test method in employee class? So it will link this. Now at the runtime it will check to which object it is referring to. To which object it is referring to? Employee object. So now origin is pointing to the employee class test method. So no change will be there. Nothing will be changed. Okay. So nothing will be changed just because origin is pointing to the employee class test method. Now what is the output in this case? What's the output in this case? What's the output in this case? Will it give test method person or test method employee? Just spell out. Test method? Employee. Definitely it will call the employee class test method. Just because the reference variable is of type employee and it will look for the employee class. If I try to compile this, no, let me go to the classes. Now which method is called? Test method of the employee class is being invoked. Okay? Test method of the employee class is being invoked. Now will it compile successful? Will it compile successful? Will it compile successfully? If it is no, you should tell even why it is no. Huh? Overriding? Not? Did I tell that if overriding is not initiated, it is a compile error? Did I tell that? If the overriding is initiated and the overriding rules are failed, then it will be a compile error. Did I tell that if the overriding is not initiated, it is a compile error? It's never like that. The overriding is initiated and the overriding rules are not satisfied, then it will be a compile error. Now, is there any other compile error? Is there any compile error? Okay. First, what it will do means, what is the reference variable we are using? See here. First, let's try to compile these classes individually. Person class is there, employee class is there, and the same name list is there for two methods. But the list of arguments is different. So it doesn't initiate the overriding; it's overloading. It's overloading and consequences. So next thing, these two classes usually will compile successful. Okay, and if you go to the calling statement, we are calling the test without sending any arguments. Test with no arguments. Now, first it will find the test with no arguments inside the employee class. Do we have test with no arguments in the employee class? No. So then it will come to this superclass. What's the superclass to employee? Person. So it will come to the person class and it will search. Do we have test method with no arguments? Is there any test method with no arguments in the person class? Yes. Now, will it be inherited to the subclass? Will it be inherited to the employee class? Is this test method inherited to the employee class? Is this test method inherited to the employee class or not? Yes. Yes. Definitely, this test method will be inherited to the employee class. Okay? So, this test method will be inherited to the employee class. So, there is some other meaning for projected. Okay, so let me make it default. Project has a different meaning. Okay, now this is a method of default access level. Now, is a method of default access level be inherited to the subclasses? Yes. So then what it will do is, now in the employee class we have a test of in I, but we are calling test with normal. So first we will check, do we have a test method in the employee class which is normal? No. So we will try to connect to the test method of the person, and we will check the access level. Access level of the test method of the person. If it is not private, then it can be inherited to the subclass. So it will link the concept to the subclass. Okay. First it will check for the method in the subclass. Okay. If it's not there, then it will check for the method in the superclass. Now it will be compiled. And obviously it will be executed, and it is calling the test class method which is person. Let's consider that the overriding is initiated. Let's consider that the overriding is initiated, and let's consider like the superclass test method has an argument of int I, and the subclass method has no arguments. Now, in this case, how it will behave? Now, what is the data type of EMP? Person. Now, can a person reference refer to employee class object? Yes, that's possible. Now, we are calling emp.test with no arguments. Okay? So, what the compiler will do? The compiler will check for the test method in the employee or test method in the person class. Definitely, the compiler will check only the reference, not the object. What's the reference? Person. In the person, do we have any test method with no arguments? No. Now, will it give a compile time error? It will give a compile time error. Just because the reference variable is of type person. Now, we are calling emp.test, and the compiler will check, okay, what is the data type of emp? What is the data type of emp? Person. So, in the person, do we have any test method with no arguments? In the person, do we have any test method with no arguments? No. So, it will give a compile time error. So, the compiler will not check to which object the reference is referring to. The compiler will check only what is the data type of the reference. The compiler will check only the data type of the reference, not the object. So it tells that there is no augmented method in the person class. Okay. So the compiler will check. The compiler always it will check only for the data type of the reference variable, not the object it is referring to. Okay. Now will it be compiled successful? Will it be compiled successful? Yes. Okay. Just because we have a test method with no arguments in the person class. Now, at the time of compilation, will it refer to the test method in the person class or test method in the employee class? Test method in the person class or employee class? At the time of compilation, will it refer to the test method of the person class or test method of the employee class? Employee class or person class? Definitely it will try to link. At the time of compilation, already I told the compiler will never check what is the object. The compiler will check only what is the reference variable. Okay? So if the compiler checks what is the reference, only what is the reference variable data type, definitely at the time of compilation, okay? At the time of compilation, this statement will build in. Now, when the also we have test, it is normal. Okay? At the time of compilation, the compiler will point to the test method, which is normalized in the person class. But at the runtime environment, what the runtime environment will do is, where EMP is referring. The runtime environment will check where EMP is referring. Where EMP is referring to, which object is EMP is referring? To which object the EMP is referring? Is it a person class object or employee class object? It is an employee class object. So, in that employee class, okay, the runtime environment will check in that employee class, is the test method overridden? Is the test method overridden in the employee class? Is the test method overridden in the employee class? Yes. So, if that method is overridden in the employee class, then what the runtime environment will do is, the runtime environment will break the bound that is established at the time of compilation. Okay? And at the runtime, it will have a link with the overridden method. So now what is the output here? Test method of the person or test method of employee? Test method of person or employee? Because it will give the output of test method of the employee. Just because at the runtime, at the time of compilation, the bond was established with the test method of the person. But at the runtime environment has seen what is the object EMP is referring to. EMP is referring to employee class object. Since EMP is referring to employee class object, if we try to find is the test method overridden in the employee class. If we find that method is overridden, then it will break the bond with the person class test method and establish a bond with the test method of the employee class. So this doesn't exist at the runtime, only this exists. So the output is test method of the employee. So that's how it will behave. Okay. Now let's consider that. Now what's the output? Test method of person. Now which method will be called? Test method of employee. Now test method of person. So now did we change the calling statement? When I change the I'm changing the method, right? See, I'm changing the method signature. Okay. Now which method is called? Which method is called? Employee class test method will be called. Now which method is called? The method of test method which is there in the person will be called. Now, in these scenarios, am I changing the calling statement? Am I changing this statement? Okay? This statement I am not changing, but the calling place, okay? The calling place is changing based on whether method is overridden or not. If the method is overridden, then the overridden method is being linked. Okay? The method is not overridden, the superclass method will be linked. So, based on whether method is overridden or not, even though the calling statement is not changed, okay? The statement, okay, the method to which the statement is linked is changing. Okay? The method to which the statement is linked is changing based on whether method is overridden or not. Actually, we are not changing the fifth statement. Even though we are not changing the fifth statement, the execution will be different based on whether the method is overridden or not. Okay? Now, can we tell that the same statement is behaving differently? Okay? When the method is overridden and when method is not overridden, we have two scenarios. In first scenario, method is overridden. In second scenario, method is not overridden. Now, in those two scenarios, is the same statement behaving differently? Yes or no? Yes. This is what polymorphism. Okay? The same statement behaves differently in different scenarios. The possible scenarios are the method is overridden in the subclass or the method is not overridden in the subclass. Method is overridden in the subclass or method is not overridden in the subclass. Now, how polymorphism occurs and how we can define polymorphism. Now, let's consider that we have a reference variable person, okay, and EMP is of that person, and we are calling EMP test. Now, at the time of compilation, what it will do is it will try to link to the test method of the person class. But at the time of execution, okay, the runtime environment will change. Is that method overridden in the subclass? Okay, is that method overridden in the class to which we have created the object? Is that method overridden in the class to which we have created the object? Is that method overridden in the class to which we have created the object? See, we have created a reference variable of person and the object of that employee. Okay? To which class we are creating the object? Employee class. Okay? In that employee class, to which class we are creating the object? That employee class, is the test method overridden? Is the test method overridden? Yes or no? Okay, just see here. Just see on the board. You don't see the screen. See on the board. Is the test method overridden in the employee class? Yes. So, what it will do is, okay, when this bond is established, when this link on this bond is established, compilation. Okay, the bond that is established in the compilation time is called as a static bond. Okay. And at the runtime, in the runtime environment, sees that okay, the method is overridden in the class to which we have created the object. Now, the method is overridden in the employee class. So, what it will do is, it will break the static bond. It will break the static bond and it will establish a new bond at the runtime. To the overridden method. To the overridden method. Okay? And this bond that is created at the runtime is called as dynamic bond. Not only even bonding. Okay? Anything that happens at the compilation time is called as static actions. Any actions that happens at the time of compilation are called as static actions. Any action that is performed at the time of execution are called as dynamic actions. Any action, just one of the action is binding. Okay? Any action that is performed at the time of compilation is called as static action. And any action that is performed at the time of execution is called as dynamic action. So, since it is binding, at the time of compilation, static binding will be there. At the time of execution, because of method overriding, dynamic binding is there. Okay? And because of dynamic binding, polymorphism occurs. Because of dynamic binding, polymorphism occurs. Now, just because the same statement is behaving differently at the time of compilation as well as at the time of execution. Now, if somebody asks you that without inheritance can I have polymorphism? Without inheritance can I have polymorphism? Okay. But as for our discussion, there is no concept of static polymorphism. As for our discussion now, can we have polymorphism without inheritance? So, how polymorphism occurs? When there is dynamic binding. When dynamic binding occurs? When there is method overriding. When method overriding happens? When there is inheritance. Now, if there is no inheritance, is there any concept of method overriding? There is no method overriding. Do we have any concept of dynamic binding? No. There is no dynamic binding. Do we have any concept of polymorphism? Now, without inheritance, can we have polymorphism? Without inheritance, can we have polymorphism? See, if there is inheritance, then only there can be a concept of method overriding. There is method overriding, then only dynamic binding will be there. There is dynamic binding, then only polymorphism happens. Now, let's consider like there is no inheritance. If there is no inheritance, okay, if there is a chance to have polymorphism, if there is no inheritance, is there any chance to have polymorphism? No. It's impossible to have polymorphism without inheritance. Okay? Without method overriding and without inheritance, there is no concept of polymorphism. Now, do we have polymorphism here? Do we we have polymorphism here. Just don't see the screen, see the board. Do we have polymorphism here, or can you call these statements as polymorphic statements? Okay, these statements will never be called as polymorphic statements. Okay, polymorphism occurs only when there is dynamic binding. Okay, polymorphism occurs when only when there is dynamic binding. But do we have a concept of dynamic binding here? See, let's consider in terms of compilation. What is the reference variable of EMP? Reference type of EMP? Employee. So, do we have a test method in the employee? Do we have test method in the employee? Yes. So, the name of compilation will be applied to test method in the employee. Now, at the time of execution, is it pointing to the same object?
Yes.
Yes. So, the static point will be continued. There is no concept of dynamic binding. Okay? Now, when we can have a concept of dynamic binding is, if the reference is of superclass and if the object is of subclass, then there can be a concept of dynamic binding. If the object and the reference are of the same type, then there is no concept of dynamic binding and there is no concept of polymorphism. Polymorphism happens only when the reference is of superclass and the object is of subclass. Now, how we can define polymorphism means the same statement behaves differently. If the same statement behaves differently in different scenarios, then it's called as polymorphism. And the possible scenarios here in Java are whether the method is overridden or the method is not overridden. But the possible scenarios in other programming languages might be different. But the concept is same. Concept of polymorphism is same in any programming language. The same statement should behave differently in different scenarios. But those scenarios in Java are whether the method is overridden or not. Okay? Now, some people will call method overloading as static polymorphism. Some interviewers still believe that overloading will come under polymorphism. If they specify about static polymorphism, then only we tell that it's method overloading. If they don't specify anything, okay, if they don't specify anything about static polymorphism, don't tell them anything. If they ask specifically what's the difference between static polymorphism and dynamic polymorphism, okay, or what is static polymorphism, then only tell about method overloading. Method overloading, some people call method overloading as static polymorphism. If they specifically ask about method overloading or they specifically ask about static polymorphism, then tell about method overloading. Now, just see the screen. Now, what's the output here? Just plot the dynamic binding and static binding in your notes so that you can understand how it will be. Now, what's the output? We'll call the test method person or test method employee. We'll give the output as test method employee. Let's see how and why it will be. Output is test method employee. How it will do is, first we have a method. We have a class person which has test method. We have an employee which has test method, and we have a permanent employee. Now, let's consider the references of that person. References of that person. Now, at the time of compilation, definitely it will be bound to the test method. Test method of the person. Just because the reference variable is of that person. Okay? The time of compilation. Okay? So now here the object is of person. Permanent employee. Okay? Now the object is of type permanent employee. Now it will check. Is the test method overridden the permanent employee? Is the test method overridden the permanent employee? No. So it will check in its immediate superclass. What is the immediate superclass to permanent employee? So in the employee, as the next step, it will check in the immediate superclass. What is the immediate superclass? What is the immediate superclass to permanent employee? So it will check. Is the test method overridden the employee? Yes. So if you break the static bond, it will establish a static bond. So now can we call this statement as a polymorphic statement? Yes or no? Yes. Definitely this statement is a polymorphic statement. Like this, at the level of hierarchy, it will check. First, it will check the class to which we have created the object. Then, if it is not there, then it will check that for that method in the superclass. Like that will do. Okay. No. What is the output? When it's 200, you want to use the method. Okay? If you call the definitely you call the test method of the employee just because it is overridden. Now, can I call the statement as a polymorphic statement? Can we call the statement in the fourth line as a polymorphic statement? Yes. Just because the compilation time it is bind to one method and the runtime it is bind to another method. Now, what's the output? It will call the test method as an employee. Then employee.id will be 100 or 200. Okay? It's 200, right? What's the output? It's 100, 200. 100. Okay, very important thing is only methods can have dynamic binding. Attributes will have only static binding. Only methods can have dynamic binding. Only methods can have dynamic binding. Attributes cannot have dynamic binding. So the attributes will point to the members of the reference variables only. Okay, if we try to refer an attribute using a reference variable, then it will be bind to the attribute in the reference class only. See, if we try to refer an attribute using a reference variable, definitely at the compilation time or the runtime, it will be bind to the attribute in the reference class only. At the time of compilation or at the time of execution. If we try to refer an attribute using a reference variable, at the time of compilation or execution, it will be bind to the attribute in the reference class only, not the object class. Ask Sun Microsystems why you have done this. That's the purpose of methods, right? See, if everything is done by the same thing, there is no purpose of classification. We can have only one member for every purpose. Okay? The attributes are specified for that class only. They are confined to that class, not to be overridden. Just because attributes doesn't have any definition. Attributes just have a value, but no definition. Methods doesn't have value, but have a definition. Overriding means redefining. Okay? Attributes have a value, but not definition. Methods have definition, but no value. To represent some value, they have mentioned attributes. To represent some definition, they have mentioned methods. Why means? It will be like that. Okay? There will be some classification between the members. The member will be used for a specific purpose. Okay, the attributes are used to represent a specific purpose so that it has some value. Okay. Question is fine, but okay, to be frank, the attitude should be changed. Okay, it should even if you call with my name or even if you call array, I don't feel anything. But okay, this is not the actual attitude you should represent yourself. Okay, if you are representing in a community, then even if it is not required, you should be a little bit polite. You should not be over polite. Definitely, you should have a little bit pride of yourself. But at the same time, your words should not reflect that you are over pride. Okay? It's not something like you have asked this question. It's not something like you have asked a question in this way in the class. It's not a wrong thing in our perspective. But it will not be the mentality of your HR. It will not be the mentality of your manager. It might not be the mentality of even your colleague. It might not be the mentality of even your friend. So, people will be of different mentalities. Not all will accept this kind of things. Okay? So, we need to change a little bit so that even if it is not required, we should be a little bit polite to make the things happen. Even in any industry where the work is involved as a group, these things are definitely required. So, the first thing that they will check in the interview is your communication and your attitude. For the attitude. How you are responding. See, when the interviewer asks you a question, okay, in the interviewer asks you, let's consider like the interviewer asks you some irrelevant question, which is not relevant to you. It's not at all relevant to you. Then he will check your patience and attitude. How much patience you have. Okay. So if you get angry at a very less time, so why you are asking this question to me? Okay, it's not at all related to me. See, the way of telling is different. I don't have much knowledge. I did not get much chance to work on it. We can tell in that way. Some people will tell that why you are asking this question to me. See, the same thing, we are telling the same thing, but the way of telling will make a big difference. Okay? Just at least act that you have some better attitude. Whether you have the attitude or not, that's irrespective. That's the second thing. At least in front of the interviewer, at least in front of the other people, act that we have better attitude. That will make the things to work. Okay? And attributes doesn't have any overriding. Okay. Only methods have overriding. That's what we have discussed now. Now, in this case, we'll give 100 or 200. Definitely it will give 100. Just because it doesn't change even if it is employee or permanent employee. Okay? It will give 100 only. No? Will give 100 or 200 or something else? 200. Just because the permanent employee we don't have any ID, so it will check for the ID in the immediate superclass. What's the immediate superclass? Employee. An employee, the ID value is 200. So the output will be 200. Understood why it is 200? Everybody? Okay. Like that it will be. And next concept is typecasting. 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 Now, typecasting can be done even for primitives or derived data types. Typecasting can be done primitives or even for derived data types. Just typecasting means changing the value into another data type. Changing the value into another data type is nothing but typecasting. Changing the value into another data type is nothing but typecasting, and this typecasting can happen either from primitives or even derived data types. Let me show you a simple example where typecasting can happen for primitives. What happens? Okay, if it is mismatched, then what happens? It will be a compile-time error. Just because we are calling the test method by sending some value I, okay, but what is the data type that test can take? Integer. But what is the value that I am sending? Double. But what is the internal value that we have? Is it integer value or a double value? It's integer value only. So in that case, what we can do is we can typecast into integer and call it. So this is how typecasting can happen in primitives. Okay, now it will be compiled as less executed successfully. Okay. Now I can typecast a higher data type into lower value, or even a lower data type into a higher value if it is a primitive. Now what I am doing is I am typecasting integer into double. This can happen. If it is primitive, then we can typecast higher to lower data type as well as lower to higher data type. It can be possible. Okay, so this will compile successfully. Okay, just because typecasting can happen from higher to lower data type or lower to higher data type in case of primitives. Okay, so this will be compiled as well as executed successfully. Okay, now, but how it will be in case of derived? Even for derived data types, we can perform typecasting. Now, what's the output? What's the output? Sorry, EMP is not there. What's the output? What is the output? It will be a compile time error, just because the reference variable is p of type person and we are calling test, which is by sending 10. Do we have test method which can take 10 in the person class? But it's there in the employee class. The same way, we have p dot salary. Do we have salary in the person class? No, salary is there in the employee class. But even if we are trying to refer to employee class object, at the time of compilation, the compiler will check what is the data type of person. What is the data type of person? What is the data type of person? Sorry, what is the data type of P? Person. So, just it will check for test method which take integer in person, just check for salary inside person, which doesn't exist. So it will give a compile time error. Okay, test and salary are not there. So what I do is I will typecast to
why is the error value called P of salary?
just because salary is not there in the person. See, salary is attribute and salary attribute is not there in the person class. Salary attribute is there in the employee class. But for attribute or a method, it will check only for the data type, not the object. Now, what we can do is I'm typecasting the person object into employee object. Sorry, I'm trying to typecast the reference into employee. Now, what happens is how I can perform typecasting in case of derived data types. The same like primitive. But there are some rules in typecasting of derived data types. In primitive typecasting there are no rules, but in derived typecasting there are some rules that we need to follow. Okay? Now, I have typecasted the person reference into employee. Now, the compiler will check only what it is. What is P? P is of type person. Now, can we typecast P into employee? We can typecast one reference variable into some class if they share some inheritance relationship. Now, what is the data type of P? Person. Now, person and employee share any inheritance relationship? Yes. So, it can be typecasted. Now, what the compiler will think like is, I am assigning employee to employee. Now, can I assign employee to employee? Can we assign employee to employee? Yes, it's possible. So, it will be compiled successful. Okay? It will be compiled successful. Leave over the part of execution, this will be compiled very successful. Now, yes. And it will be even executed successfully. Now, what I will do is, let's consider that I am not making any call. Now, will it be compiled successful? Will it be compiled successful? No. Why it will not be compiled? Just because we have a P which can refer to employee. That's fine. We are trying to typecast P into employee. Is it fine? Can we typecast P into employee as per the compiler? Yes or no? Yes. Just because P is of type person and employee has an inheritance relationship. But, okay, what it will do? It will try to assign employee to student. But can I assign employee to student? Is it possible? No. So, it will be a compiler error. The compiler will tell that on the right hand side it is employee, on the left hand side it is student. So, on the right hand side it is employee, but the required is student. So, the assigning value should be compatible. Okay? Let's consider that. Now, is it possible to assign like this? Now, in this case, will the compiler give any error? Yes? Why? Why it will be compiled some error? Person? Did I tell that a superclass, a subclass reference cannot be typecasted into superclass? Typecasting can happen anywhere if there is inheritance relationship. As per the compiler, typecasting can happen if there is an inheritance relationship. As per the compiler, typecasting can happen if there is an inheritance relationship. Now, this will be compiled very successful. Okay, it was compiled successfully. Okay, it was compiled successfully. Now, is it possible? Is it possible? Yes or no? Is it possible? Yes? See, first what we are doing, EMP is of type employee. Okay? Now, can employee object refer, can employee reference refer to employee object?
Yes.
That's fine. The first line is compiled very successful. The second line, I'm typecasting employee into person. Can I typecast employee into person? Yes or no? As per the compiler, we can typecast employee into person. But what the compiler will think? We are assigning person. Now, on the right hand side, we are assigning person. On the left hand side, what it is? Employee. Now, can I assign person to employee? Can I assign person to employee? Typecasting can happen if there is an inheritance relationship. But on the right hand side, if it is a bigger one, on the left hand side, it is a smaller one. Basically, it will be a compile time error. Okay? See, only in typecasting, any subclass to superclass or superclass to subclass is allowed at the time of compilation. But while assigning, definitely it will check the relationship, whether it is a superclass or subclass. Only while typecasting, okay, it will check. Just it will check only if it has an inheritance relationship or not. It might be a subclass to superclass or superclass to subclass. But while assigning, definitely it will check whether it is a subclass or superclass. While typecasting, any inheritance relationship is valid while typecasting. Whether subclass reference to superclass class, superclass, or superclass reference to subclass at the time of compilation. But while assigning, definitely it will check. The left hand side can be the same or even superclass, but it should not be subclass. But here, if you see here, on the right hand side we have person, on the left hand side we have employee. So person cannot be assigned to employee. So this will be a compile time error. Telling that person cannot be assigned to employee. Let me go back to the previous example. Now, is it possible? Is it possible to typecast like this at the time of compilation? Yes? Now, which method is called at the runtime? The test method of the person class or the test method of the employee class? Now, which method will be called at the runtime? Test method of the person class or test method of the employee class? And because of typecasting, a new object will not be created. That's for sure. Because of typecasting, a new object will not be created. Will it make a call to the person class test method or employee class test method? See here, to which class we have created the object? Person class. Then, in this case, will it call the person class test method or employee class test method? If we have created an object to a person class, will it call the person class test method or employee class test method? Okay. It will not be person class test method. At the same time, it will not be employee class test method. It will be a runtime exception. The compiler will compile it very successful. Okay? The compiler will compile it very successful. But at the runtime it will be an exception. What's the exception? Okay? Exception in thread meant class cast exception. It's a class cast exception at the runtime. It's a runtime exception. The compiler will compile it very successful, but at the runtime, okay, it's giving a runtime exception with the name class cast exception. Okay, when the class cast exception occurs means, okay, if the superclass object, is typecasted into subclass, the superclass object is typecasted into subclass, then it will be a class cast exception. The superclass object is typecasted into a subclass, then it will be a class cast exception at the runtime. But as per the compiler, any reference variable can be typecasted into any class if there is an inheritance relationship. But at the runtime it changes. At the runtime the typecasting rules will be changed. At the runtime for typecasting, what it will do means, okay, if the object is typecasted into a subclass, then it will be a class cast exception. The object can be typecasted into the same class or even the superclass. The object can be typecasted into the same class or even the superclass. The object can be typecasted into the same class or even the superclass, but not the subclass. The object can be typecasted into the same class or even the superclass, but not the subclass. Be compiled, and when at the time of execution, it's giving a class cast exception. So blindly we can tell that if the typecasting list contains at least one subclass, see, the typecasting can contain any number of classes like this. Now person is possible and person to employee is possible at the time of compilation, just because they have some inheritance relationship. But at the time of execution, it will check. Can I typecast P to person? Yes, just because both are the same. This is person and this is person. And can I typecast P to employee? Can we typecast P to employee? No. So that there can be multiple classes in the typecasting list. But if the typecasting list contains at least one subclass or irrelated class. If the typecasting list contains at least one subclass or irrelated class. If the typecasting list contains at least one subclass or irrelated class, then it will be a class cast exception at the runtime. So, now, will it give a class cast exception at the runtime? Yes or no? Yes, just because P is of type, P is referring to object of person. Now, object is of type person. Now, P is referring to object of type person. Okay? Now, at the runtime, it's being typecasted into employee. So, if at least one class is a subclass or irrelated class, definitely it will be a class cast exception. So, even in this case, it will be a class cast exception. So, it is a class cast exception at the runtime. So, first we check for compilation errors. If there are no compilation errors, then we need to check for runtime exceptions. If there are no compilation errors and runtime exceptions, then only we need to check for correct output. Okay? Let me complete. Now, will it give a class cast exception at the runtime? Will it give a class cast exception at the runtime? Why it will give a class cast exception? Okay, now let's come from the compilation. Now, at the time of compilation, person, there is a person class reference P. Now, can P point to employee? Yes, it will be compilation. Compile. Now, come to the next statement. Now, what is the data type of P? Person. Now, can I typecast person into person? Yes. Can I typecast person into employee? Can I typecast person into employee as per the compiler? That's why I told clearly, at the time of compilation, it will not check any subclass or superclass relationships. Okay? Just it will check whether they are related or not. Whether they are sharing an inheritance relationship or not. It will not check whether it is a subclass or superclass. At the time of compilation, it will not check whether it is a subclass or superclass. At the time of compilation, it will check whether they share any inheritance relationship or not. At the time of compilation, it will check whether they share any inheritance relationship or not. Okay? So, is P sharing any inheritance relationship with person? Is P sharing any inheritance relationship with employee? Can I assign employee to employee? Yes. So, it will be compiled successful. But at the time of execution, what it will do? Now, the time of execution, it will check where P is referring to. Where P is referring to? Employee class object. Now, the P is referring to employee class object. Now, is there any subclass to employee? See, at the runtime, it will not check what is the reference. At the runtime, it will check where the reference is pointing to. Where the reference is pointing to which object the reference is, to which class object the reference is pointing? To which class object the reference is pointing? Is it the person class object or the employee class object? The reference variable is pointing to employee class object. Now, at the runtime environment will think in the context of the object only, not the reference variable. See, at the runtime it will check to which class the object is created. To which class the object is created? Employee. So, now, for employee, is there any subclass in the typecasting list? For employee, is there any subclass in the typecasting list? Yes or no? No. Is there any irrelated class in the typecasting list? Yes or no? No. There is no subclass as well as there is no irrelated class. See, person is related class, right? They have an inheritance relationship. So, there is no subclass and there is no irrelated class. So, it will compile as well as execute successfully. Just because at the time of execution it will not check what is the data type of the reference variable. The runtime environment will check to which class object the reference variable is pointing to. To which class object the reference variable is pointing to? Employee class. So the runtime environment will check P is pointing to employee class object, and is there any class in the typecasting list which is a subclass or a related class to employee? Is there any class in the typecasting list which is a subclass or a related class to employee? No. So it will compile as well as execute successfully. Okay? Now, will it be compiled successful? Will it be compiled successful? Let's see. Okay? First, person is there and person can point to employee class object. Now, the compiler will check what is the data type. What is the data type of the reference variable? Person. Now, can I typecast a person to person? As per the compiler, we can typecast even person to permanent employee just because they share inheritance relationship. Can we assign permanent employee to employee? Yes. So, compilation will be successful. At the time of execution, the runtime environment will check to which object, to which class object the P is referring to which class object P is referring to? Employee. Now, the P is referring to employee. Now, is there any subclass or irrelated class to employee? Yes or no? Yes. There is a subclass to employee which is permanent employee. So it will give a class cast exception at the runtime. Okay? So it will give a class cast exception at the runtime. Compiler is compiling successful, but at the runtime it is giving a class cast exception. Okay? Now will it be compiled successful? Will it be compiled successful? Just see the inheritance relationships and tell the answer. Will it be compiled successful? Yes or no?
Yes.
Not getting the answer from everybody? Just think for 1 minute and tell the answer. Will it be compiled successful? Yes?
Yes.
Definitely yes. Just because, see, person can refer to employee class object. That will be compiled successful. Now, the compiler will check what is the data type of person, P. What is the data type of P? Person. Can I typecast P into person? Can I typecast P into student? Yes. Definitely. Can I assign student to student? Yes. Now, how it will behave at the runtime? How it will behave at the runtime? Will it be executed successfully? Yes sir. Will it be executed successful? No. Just because? Okay. At the runtime it will check to which object P is referring to. To which class P is referring? Employee. So, can you typecast employee into person? Can we typecast employee into person at the runtime environment? Yes. It can be superclass. Okay? Can we typecast employee into student? No, just because it is a irrelated class. So now it will give a class cast exception at the runtime. Okay? Many of the guys will be confused with the class exception when it will be occurred. Okay? Just at the time of compilation, check what is the data type. And the typecasting list contains related classes or not. At the time of compilation, check what is the data type of the reference variable and check whether they share any inheritance relationship or not. Okay? But at the time of execution, check to which object the reference is pointing to and check whether there is a subclass or irrelated class. If there is a subclass or irrelated class in the typecasting list, definitely it will be a class exception. Subclass or irrelated class to the class for which we have created the object. At the runtime, we need to check anything in the context of the class to which we have created the object. At the compilation time, we need to check in the context of the reference variable. At the runtime, we need to check in the context of the class to which we have created the object. Understood? That's how it will be now. Now, will it give a class exception? Or will it give a compile time error? Or will it be compiled and executed successfully? Is there any other answer? Will it give a compile time error? Or will it give a class exception? Or will it be executed successful? It will definitely give a class exception. Just because person can point to P can point to person class object, that's fine. And P can be typecast into person as well as student, just because person is a superclass to student. Now student can be assigned to student, so it will be compiled successful. By the time of execution, to which object P is referring to? Person. Now, person can be typecast into person, that's fine. But person cannot be typecast into student as per the runtime environment. So, it will be a class exception at the runtime. Okay? Now, what's that? Why it will be compilation error? Person cannot be assigned to student. It will think like I am assigning person to student, but it's not allowed. So it will be a compile time error. Okay? Now, will it be a compile time error or runtime exception, or will it be executed successfully? What will it do? Will it be a compile time error or runtime exception, or will it be executed successfully? It will be executed successfully. Just because person can point to student, as well as person can be typecast into person, and person can be assigned to employee. Sorry, person can be assigned to a person. Now, at the time of execution, student. and the typecasting list doesn't contain any subclass, so it will compile as well as executed successfully. Okay, output is test method person. Now, what's the output? What's the output? Test person or test employee? Will it be compiled successful? Is there any runtime exception? Is calling test method person or employee? Employee. So just okay, irrespective of the typecasting, okay, the methods will be executed, okay, with respect to the object that we have created. Okay, the method's execution will be done with reference to the object that we have created. But this is a very unusual case. Okay, typecasting a subclass object into superclass is very unusual. It's very unusual case. In general, we won't do that. Even if it is possible, we won't do that. Okay, it's very unusual. Just because directly using the superclass reference, you can access the superclass members. You need not to typecast the subclass object into superclass reference. But it is possible, it is allowed. But it is rather unusual. Okay? But typecasting like this is very frequently used. This is very frequently used typecasting. Okay? The reference variable of superclass and the object is of subclass, and we are typecasting the superclass reference into subclass. This is a very frequently used typecasting one. In this case only typecasting is preferred. The reference variable is of superclass and the object is of subclass.
If they are EMP dot ID, which one will be prepared?
EMP dot ID. Okay. Definitely the reference variable will be given the preference. What's the reference variable? EMP. What's the data type? Employee. Definitely employee class ID will be preferred. Now, let's consider that I have a class Now let's consider like I'm calling now. What should be the output? What's the output? Will it be a compile error? Now what is on the right hand side? Person minus dot get person. What I told? The compiler will check the data type for variables, return type for methods. Then what the compiler will do? See the compiler what it will do? Just it will check the data type for attributes and return type for methods. Okay? So what is the data type? What is the return type of the method? What is the return type of the method get person? What is the return type of method get person? What is the return type of the method get person? Is person or something else? Person. So now on the right hand side it will think that there is person. Now can I assign person to employee? Understood or not? Understood? See on the right hand side we are calling a method. On the right hand side if we are calling a method means the compiler will check for the return type of the method. What is the return type of the method? Person. So on the right hand side the compiler will think that it is person and I am assigning person to employee. Now it will not be compiled just because on the right hand side it is person which is a superclass, on the left hand side it is employee which is a subclass. Okay, person cannot be assigned to employee. Now let me change the data type, return type to employee. Now will it be compiled successful? If I change the return type of employee, then will it be compiled successful? Will it be compiled successful? See, let me come here. If it comes to the if, then the return value is object of employee class. Okay. Now, can employee class return through employee return type? Can employee object return through employee return type? Yes. Now, let's consider like if it is else case. If it is else case, we are returning a student class object. Now, can we return a student class object through employee return type? Can we return student class object through employee return type? Yes or no? But whether if it is executed or else is executed will be known only to the runtime. Compiler will check all the possibilities. If the if block is executed, when the if block is executed, is it a compatible return value? Yes, just because employee and employee. If the else block is executed, when the else block is executed, is it a compatible return value? Is it a compatible return value? When the else block is executed, is there a compatible return value? Yes or no? No, just because the return value is of type student, but the return type is employee. There is no relationship between student and employee. So it will give a compile time error. Okay, where it is giving a compile time error is showing here. Just because we are returning a student, but the return type is employee, which is incompatible. Now what it will give? Will it give a compile time error? Yes or no? Yes, it will give a compile time error. This is the previous example only. So, to avoid these scenarios, okay, what we do is Now can we typecast into employee? Can we typecast into employee? Yes. Just because the object that is returned at the runtime will be of employee only. See, at the time of compilation, it will be compiled very successful. Just because at the time of compilation, the compiler will check what is the return type of get person. What is the return type of get person? Person. As per the compiler, can I typecast person into employee? As per the compiler, can we typecast person into employee? Yes, just because they are related. Okay, whether it is a subclass or superclass, it will be verified only at the runtime. At the time of compilation, the compiler will check only whether they have any inheritance relationship or not. Okay, so the return type is person, and person can be typecasted into employee as per the compiler. So, can I assign employee to employee? Yes. So, it will be compiled successful. At the runtime, what happens? It will go to get person method and we send value 10. If we send value 10, which class object will be written? Which class object is written? If we send a value 10. If we send a value 10, which class object is returned? Employee class object. Now, can we typecast employee class object into employee? Yes. Can we assign employee to employee? Yes. So it will be executed successfully. Now, understood the value of typecasting? Understood the usage of typecasting? Okay? This is how we use typecasting in general. Okay? The typecasting might be little bit confusing. Even we have discussed n number of examples regarding typecasting. But if you practice the things, then you can understand better. Okay? Try to practice the things. If you have any doubts regarding typecasting, ask those questions in the next class. In the next class, okay, we will discuss about constructor chaining. Okay? We'll discuss about constructor chaining. This class is very important for interviews. Definitely. The typecasting or overriding, okay, or even the polymorphism, when we can call it as polymorphism. All the things that we have discussed in the today's class are very important for interviews. Tomorrow, same time 6.